Okay, so we're still lecture one. This is the middle third, and let's just go ahead and get into the syllabus now. So back here at the main page. Okay, see, you might maybe flick the lights off for now. Yeah.
I'm gonna go put the trailer away, get the truck parked.
Oh, super. And then I think we'll have the 102. Is there something for the 102 guys to do this afternoon with it?
They can stand it up.
Yeah, let's do that. Okay, perfect, thanks. Okay, so here's and just speak up if it's too dark. Like a second ago it was too bright. If we could, maybe everyone brings a little reading lamp in, I don't know. Well, let's look down through the shell first. And what I've tried to do with the shell is just, lay it out week by week with the title of the week's topic. So next week we'll get more into the recycling technology writ large. What is it? What are the different streams? What are the different strategies? Kind of big picture stuff. Similar to what we do in 101 and 102. Just look at how much matter flows through the technosphere. Week 3, we'll look into embodied energy. And here's where, in my mind, energy technology and recycling technology have a fantastic overlap. If you think back to Einstein's equation, E equals mc squared, you've got E, energy on the left-hand side, you've got M on the right-hand side. In my mind, recycling is sort of the M. It's the matter. We're looking at how matter moves around, and obviously we're not doing relativistic things. But when it comes down to it, when you set something on fire, if even a campfire, some of the matter that was sitting in the wood and sitting in the oxygen leaves that campfire as radiation, right? I mean, you can feel the heat. You can watch the light leave. So even at some very simple combustion process like that E equals mc squared is always lurking. So you can't destroy energy. You can't destroy matter. And so at its foundation, what we're really looking for. Hey, what's up, Sean? What we're looking for is, how do we, in a societal sense, not necessarily in a physics sense, conserve matter? So that's where this embodied energy, I think, kind of is a neat complement to the energy technology that we've been studying. Landfill practices, so we'll just kind of look to see how the landfill has become a default solution for a lot of the waste that we make. And I think what we're going to find is it's an economic solution more than anything. It's an easy thing to do. It's a time saver. It's a money saver, et cetera, et cetera. But then, in almost any one of these problems, this is true in almost any problem you ever deal with. It's either you deal with the problem now or you deal with it later. You can, right? Okay, so it's maybe the future is now and it's later and it's time to pay up. So, and in almost any circumstance, you're going to have a now versus later problem. So, we'll look in the glass during the introductions. I know a lot of people were really interested. What does one do with glass? Should the bottle remain the bottle? Should wine go back in the wine bottle? Should water go back in the water bottle? Should the thing be repurposed for something else? Should it be crushed? Should it become a filter? Should it be turned into a building? We'll look at all those. Cellulosic materials, we were talking a little bit earlier about composting. So cellulose is the main fiber in wood or any plant matter, really. And so we'll look at that. Should that become a composted material? Should it become a clothing material, building material, what have you? Energetic. So we'll look at that. We'll look at metals. So this will be kind of our conventional steel, aluminum, base metals. Metals too, we'll look into more like gold, silver, platinum, precious metals, things like that go into electronics in tiny little amounts. And then how do you put in the time, the energy, et cetera, to get that back out? We'll do something for the midterm, summarizing what we've seen so far. There'll be problems basically that just cover lecture. This is the first time I've given this course, so I'm going to let the midterm kind of happen on its own based on what happens in lecture, what kind of question comes up, and how we can dig down into that a little bit. Then we'll get into plastics. Plenty going on there. We just had a discussion earlier about where these plastics end up, and it's a tough problem. I even think about the plastics that end up in dryer lint, for example. When your little PET fiber comes off. I've got a friend who says, well, gosh, I just take my dryer lint out and let the birds nest with it. And so, gosh, to some extent, you got to think that, if plastic were not toxic, and some plastics are, if plastics were not toxic, they would be illegal, but, you could ingest a certain amount of plastic and not affect yourself too adversely, but we'll see. I mean, it's sort of, and it can be a research project later. We'll just see, where that little stuff ends up, because there, as of now, there are not that I know of anyway. There are not biologically derived enzymes that break those bonds, right? There's no ethane enzyme that's going in, breaking down those carbon bonds, and that's basically what it gets into. So that's what we'll do for plastics. Organic waste. We'll touch on as well, and that's going to be mainly your composting. We can look both at wet and dry organic waste, and I'll show you some examples of how. Beg your pardon?
Sewage as well.
Yes, I think we should definitely look at sewage. There are, and it's funny how these things come around. I can show you some case studies from the Philippines. They have a big issue with their sewage management. We could even get into, and in fact, that might, I don't have a specific section on it, but that might be a good place to get into some waste to energy. So right now, if you put a methane sensor on top of just about any sewer lid, landfill, what have you, where there are organic waste, you're going to see methane coming off. And the question is, well, gosh, could you not monetize that? Wouldn't it be better to turn that into something other than just, let it go as a greenhouse gas? So yeah, good thing to bring up during the organic waste portion. Electronic waste, it's always increasing, and kind of, and it's a weird race to the bottom a lot of times with electronic waste, because previously, to have a reasonable conductor, you needed, a substantial amount of gold, silver, platinum, these valuable metals. Anymore, the engineering is such that you can get away with having a reasonable device with even less of the precious metals in them. Now, that becomes a problem, because then you have to potentially invest more energy just to get back what little gold is in there. So that's something that we'll look into. Hazmats, these are going to be things that, heavy metals, dioxins. We might look a little bit at nuclear waste. For example, the hospital here in town, there's a lot of protocols that rely on trace radioactive materials. So what do you do with those things? Now, this last one, I'm a little sheepish going towards. I would like to introduce this a little earlier. What is it? It's just week 1. I'm thinking by week 3 or 4, I'd like to take you over to a lab we have across town and take a look at this solar forge that we built a few years ago what we're going to find, getting back to that whole E equals MC squared thing, what we're going to find is anytime you're trying to separate different components of matter from each other, you're going to have to put some kind of energy in. And it's going to be either mechanical energy, grinding something up, thermal energy, getting it hot so the materials move away from each other, or some kind of chemical energy. And so, in my mind, most of the fundamental chemical energy that we have access to at one point or another was a photon hitting a plant. I mean, most of the fundamental chemical energy that we have access to is really old solar energy. And I would like to, use as little of it as possible, whether you want to say, well, we want to preserve the fossil fuels for future generations. Well, maybe you do. Maybe there are appropriate ways that we could use that better in the future. Being a mechanical engineer, I always look for the simplest mechanical solution. How do you just kind of do something without chemicals first? But then at the end, though, at some point something's going to get hot. So the third energy that we're talking about, first you got your chemical and you got your mechanical. Third one is thermal. Getting something hot is going to be a way to break materials apart. Solar forge, gosh, you've got direct access to the sun. If you can focus that, and we have, we built a solar forge 2 years ago and actually did a lot of electronic precious metal waste recovery with it. We didn't have to set anything on fire. Well, tried not to. So once in a while things did catch on fire. This was pretty hot. We didn't have a vacuum oven for this, but this could be something, if somebody wanted to pick this up as a technology, hey, I'm going to make a solar forge, nothing's going to catch on fire, light volatile molecules come out the top in gas or liquid form, heavier stuff goes to the bottom, that's where my heavy metals are. So that's a project that I see being really cool, zero carbon, recycle technology down the road. So if somebody wants to dig into this now, let me know. We'll fire up the forge here while we still have some sunlight in the fall, and maybe look towards a zero waste solution using that. Yeah, Shelley.
Can we melt gold?
Yeah, I think we could. We were able to melt zinc very easily. We melted lead very easily. We were not able to hit glass melting temperatures. I don't know what the melting temperature of gold is off the top of my head, but I'm almost positive we can melt gold with this thing.
We would try.
Yep. Yeah, and worth a shot too. So good question. All right. So that is the middle shell. And one thing here, I'll just do this right now while I'm thinking about it, just to make it a little bit easier. There's a light bulb here I can turn on. So we're in week 1. I try to just list it week by week rather than date by date. I don't know if you guys do this or not. I try to do the same thing in my Outlook calendar. It just keeps it straight for me, and that's how I label the lectures too. And if I show you here, I just have week 1 listed here. I'll scroll through the next one. There's week 2, etc. We do have a recycling tour coming up. This is a 4-hour course. We're doing 3 hours of lecture per week, but we'll also have at least 1 hour of outside activity. We've got one thing set up with facilities next Wednesday. We're going to meet with Kerry over there, and he's going to show us some of the challenges, opportunities that he has for us. But anyway, there's week 1, there's week 2, week 3, etc. So that's how I tend to organize the course and the shell. And you can see also that first lecture, that first segment that I just gave is here. I will then just post these guys. Let's see how it turned out. All right. Hey, so good morning, everybody. It is Tuesday, September 1st, 2015. And so pretty easy lecture. Pretty easy to catch. So no excuses for missing lecture. They're right there 10 minutes after we finish. So. all it's doing is just capturing my whole screen, right? So you'll be able to see that, just like you would with the Khan Academy or anything like that. So everything will be there. You won't miss a thing. Okay, so this light bulb is on for now. Next week I'll turn this light on, finish up our introductions, and there we go. Here's the syllabus. Since this is a co-convened class, I put the Missoula College logo at the top. Our department, in case you were not aware, is now called the Department of Applied Computing and Engineering Technology. A lot of students that come through the energy tech, information tech, or electronics tech programs take those credits and then turn them into engineering degrees. I've got a few students that are pursuing engineering degrees right now. As you probably know, energy technology is one of the 3 programs within our department. So it was a pretty big deal to be renamed engineering technology. It's a formally recognized two-year degree, and we've been getting a lot of interest from Montana State and also Montana Tech to say, how do we partner better so that the courses that we offer here dovetail better into what they're offering there. Could even be that this recycling tech dovetails into some of the mining curriculum. So we get into metals and things like that. Could be that that's of value to the miners in Butte. I finally convinced the administration. It was somewhat of a fluke, but that we should always offer online, which is a 5.0, and face-to-face sections of every single course. The dean's office was worried, well, if we only have a handful of students in the online and only a handful of students in the face-to-face, then our numbers look bad because we don't have enough students per class. Well, it's the it's the age of the MOOC, and it's the age of online education. So the subject matter is the same as we just saw between the online section, which is the 5.0, and the face-to-face, which is the 01. These are the 2 CRNs. Somebody asked you, just course registration number. Environmental science, there's a single CRN. It's online and face-to-face. It might affect your tuition. It might affect whether you have to go get shots at Curry Health Center, but I'll leave that up to you. So it's all the same to me. Tuesday, Thursday, 10:30 to noon. We'll probably start around 10:40 and definitely wrap up by noon. I have 3 to 4 field trips will be provided. I already mentioned the one we're going to do next week with our own recycling facility here on campus. I also mentioned the fact that we'll be over at our partner institution, the Hive, across town, where our solar forge is located. I've also been stockpiling some unconventional recyclables. So I've got a giant pile of styrofoam sitting over there. I have a lot of shredded thin films. 2 years ago, we took a month worth of plastic bags from Albertsons, ran it through a 75 horsepower shredder, turned it from a pile of squished bags into several buckets of nasty plastic. And the question is, well, why the heck would you do that? Well, what else are you going to do with this stuff? And right now, there's an EPA-approved facility in Wisconsin to turn waste into energy, to turn the hydrocarbon bonds sitting in the thin film plastic bags into heat and electricity. And someone's like, why the heck are you going to burn plastic? Well, why are you burning coal? Coal has the mercury, the lead, the heavy metals have already been taken out of the plastics. It's a hydrocarbon, and it's renewable, it's sustainable, at least for the time being, until we outlaw it, ban it, and go to fully organic fibers, as we were discussing earlier. Anyway, so you'll get to see that as well. And I've been discussing with one of the entrepreneurs here in town, how do we gather up all that stuff and turn it into something that's an alternative to burning virgin fossil fuels, if you will. Okay, there's a couple field trips. If something else suits your fancy, if you want to go check out some other recycling facility, let me know. I've also got the opportunity, right now, I've been partnering with Martin No Runner of IE Recycling. He's been providing a curbside service, and through my PLLC, I talked to him, convinced him, negotiated with him, what have you, to offer a zero landfill service on a pilot basis in my neighborhood. So those letters are going out right now, and that would be a great opportunity to do some hands-on. So Martin has a couple employees here in town, and if you want, and I've already talked with our liability folks here on main campus. They're like, yeah, if students want to go right along with a local recycler, they're not going to get workman's comp and all that, but they will be covered if something happens. If you cut your hand on a tin can or something like that, you'll be able to sort of see this firsthand and interact with homeowners who are just as passionate about figuring this out as we are. So that's another opportunity, would be to go with IE Recycling, and we'll do that once a week on either Wednesdays or Fridays. Martin's still trying to work that out. It's probably going to be Wednesdays. It's probably going to be a morning. So if you're interested in doing a ride-along, it would be Wednesday morning with Martin and IE Recycling, and actually, be part of the solution. We might even videotape it. I've been talking with OSHA. They do offer a 10-hour materials handling safety course. So I thought I'd have David DeFreer from Helena come over and provide that. It would be a couple days in a row, like a Thursday, Friday. We'd do that instead of lecture. If I can get him here on the weekend, maybe I will, but it's 10 hours, and he goes through, gives you the information, you take a test, and then you've got a OSHA 10 in materials handling. I think that'd be an important certificate to have. So I've been on the phone with him, and I'll get him here before the semester's out.
What about hazmat?
Hazmat's a little more involved. It's more like a 40-hour deal, but we should ask him the question and see what kind of. I've inquired about the hazmat. Usually you have to go to them. For better part of a week, and I didn't want to disrupt the class too much, but it could be something that we arrange, maybe over winter break, but another good certification to have. When we took down the hydrogen fueling station and the wind turbine, we had to follow LEED standards. We actually accounted for every bit of material that was on that site, all the scraps. We were able to triage it, recycle it, so we were sticking to the LEED standard, which is also sensitive to recycling practices. ANSI is the American National Standards Institute. We should dig into that a little bit more. It's very stringent. I don't know that much about it, but this class would be a good opportunity to do it. There's also the Interstate Renewable Energy Council. They do not have a recycling standard, but over the course of this semester, we'll see what we come up with in terms of providing a standard for the university. I've got some very definite ideas about what the university needs to do to improve its recycling. And maybe at the end, we just submit it to IRAC and say, hey guys, this could be your code for providing one, because they don't have one yet. Career opportunities, I already mentioned IE Recycling. As a result of this e-waste recovery that we ran 2 years ago, a little e-waste recycling company popped up here in Missoula, so it's starting to happen. I also mentioned the Adams Center. They're keen to work with us. Boiler and incineration standard, I just mentioned that waste to energy with the plastics. That's something we also need to look into. And I think in the interest of the environmental studies students, I think it's important that we look at biomimicry. Our bodies have a whole set of organelles. Their only purpose is to eliminate waste in cells, get that the heck out of here. Same thing in a larger ecosystem, how do the waste products of one organism feed the energy needs of others? So, love to look into that. And also, I encourage you to sort of go about your day to just listen to see how many times the word trash and the word garbage get used. I try not to use them anymore because I think it's just sort of part of our lexicon, part of society, and so I've just I don't use the word trash or garbage. I just use it as, waste or materials or paper or metal or whatever the heck the thing happens to be. Yeah, Shelley.
I think we need to change the signs on the trash or garbage cans and put land.
Oh, yep, yep.
For the whole universe.
I like that. Yeah, so I've been doing a little Airbnb at my house, and I kind of thought originally that by selling or advertising my house as a zero landfill residence that I would attract more people, but I think it was a little scary. Like, what the heck is this guy? But I like your suggestion though, Shelley. And so right now we've got just kind of the little tiny Euro cans at the house, and it just says landfill right on, because people are like, where's your garbage? I don't see your garbage can. Well, it's kind of nowhere, everywhere. But it was a compromise that my wife and I made. She's like, listen, people just want to put their chewing gum or their whatever in the garbage, and so it's their little safety, security. It's going to go in the garbage, and sometimes I dig through it and triage it. Sometimes I just kind of pick my battles and let it happen. But yeah, I like the idea of calling the landfill. That's what it is.
And they've done it out in different parts of the country, like the train station.
Yeah,
And
airports.
It has changed, because before you stick something, you see landfill, it does change and then sometimes you will take it and put it in right there.
Make that decision, right.
Yeah.
Yep.
Because it's more real at that point.
Yeah.
Trash, garbage,
Yeah,
there's nothing.
yeah, no, I like it.
Yeah.
Picture, yeah, a bunch of seagulls choking on plastic bags, yeah.
At the very least, at least let people know where it's gonna go.
Yeah, yeah,
Awareness is a
yeah,
huge issue.
yeah. Okay, so homes, commercial buildings,
Actually, our jobs will be a lot easier if awareness is promoted,
mhm,
because we won't be out there trying to do it all ourselves.
yeah. Yeah, no, I think once these things catch on, people start to get it. Okay, the book has been ordered. A couple people have bought it on Amazon. We'll refer to it. I'm not going to read the thing to you. I'll read through it as you do. There'll be a few questions on the exam. I'll let you know what the important highlights are, things we want to focus on. Amory Lovins, if you haven't read him or heard about him, I strongly suggest looking into him. He's kind of one of those crazy environmentalists 20, 30 years ago, but now he's got the Defense Department knocking on his door trying to figure out how to really do energy security in the United States. I already mentioned Ted Carnes. We'll look into his book a little bit as well, take some snippets out there. When we get into some of these things, you really have to just protect yourself. And we'll probably run some glass crushers out at Martin's, so you want to protect your hands, ears, eyes from that type of thing. Same thing if you're riding along with Martin, you're going to want to have protective clothing. I think the rest is pretty straightforward. Just keep the communication lines open. I'm answering emails 2 or 3 times a day. We'll have quizzes. We might have something this week. I think just participating in the forum is going to be your quiz grade for this week, so I wouldn't worry about that a whole heck of a lot. And I think I'll probably also use this course to have some essay questions, kind of open-ended. Okay, just tell me how you're feeling, what you're thinking, what the solution is, and I'll learn from you on that. So again, let me know if you can't hit a deadline. That's it, yeah, so I'll let you read through the rest, and we covered this already. The provost calendar is happy, or helpful, if you can keep track of the weeks that way. If you need to drop the course, you can do so at the end of next week. If you have a friend that wants to add the course, let them know. Be happy to have them in here. Email. That's it. All right. So, well, any questions on the syllabus? Pretty easy, straightforward. Okay. All right. There's